Hello everyone. In last video we have derived the equation of trajectory of a projectile, and then we have derived some expression for projectile motion like time of maximum height, time of flight, and maximum height of projectile and horizontal range. In today's video we will determine the condition for maximum horizontal range, and we will show that there are two angles of projections for the same horizontal range, and we will also calculate the velocity of the projectile at any instant t and at the end point of the flight. So let's start. So first of all, the horizontal range. So in the previous video we have derived the expression for horizontal range. Now the condition for the maximum horizontal range. Horizontal range is given by r equals to u square sine 2 theta by g. In this case, the r will be maximum when the sine part will be 1. That means sine 2 theta will be 1, and sine 2 theta will be 1 when sine 90 degree. That means we can say that 2 theta equals to 90 degree, and from here we can find theta equals to 45 degree. Thus we can say the horizontal range of a projectile is maximum when it is projected at an angle of 45 degree with the horizontal. That means if we throw the projectile at an angle of 45 degree with the horizontal, then the horizontal range of that projectile will be maximum. That means it will go to the maximum distance. Now the maximum horizontal range is given by, if we put the value sine 90, then it will be u square into 1 divided by g. That means our maximum horizontal range will be rm equals to u square by g. Now two angles of projection for the same horizontal range. The horizontal range of a projectile projected at an angle theta with the horizontal with velocity u is given by r equals to u square sine 2 theta by g. Now if we replace theta by 90 minus theta, we will get r dash. That will be u square sine 2, and theta will be replaced by 90 minus theta divided by g. Then if we simplified it, it will be u square sine 2 into 90, 180 minus 2 theta. And from trigonometry, we know that sine 180 minus 2 theta can be written as sine 2 theta. So this expression and this expression is same. So we can say r dash is equals to r. That means this horizontal range and this horizontal range, when we had replaced theta by 90 minus theta, r becomes equal. That is r dash equals to r. So hence, for a given velocity of projection, a projectile has the same horizontal range for the angles of projection theta and 90 minus theta. Now clearly r is same for theta equals to 15 degree and 75 degree. If we take theta 15, then 90 minus theta will give us 75 degree. Now if we look at this graph, height versus range, then we can see that for theta equals to 15 degree, this point, and theta is equals to 75 degree, the horizontal range are become equal. This is the horizontal range for theta 15 and 75 degree. Similarly, if we see the theta equals to 30 graph and theta equals to 60 degree graph, the horizontal range are equal. And for maximum range, theta is equals to 45 degree. So when the angle of projection is 90 minus theta with the horizontal, the angle of projection with the vertical is theta. So when it is theta with the horizontal and 90 minus theta will be with the vertical. So it says when the angle of projection is 90 minus theta with the horizontal, the angle of projection with the vertical is theta. So this indicates the horizontal range is same whether theta is the angle of projection with the horizontal or with the vertical. So from this graph, and this graph shows that r is same for angle of projection theta with the horizontal or with the vertical. So this is the theta with the horizontal, and this is the range, and this is the theta with the vertical, and the range is also same. Now we will find the velocity of projectile at any instant. So as shown in figure 4.73, So we can see that this figure, look at this point P, Pxy, the resultant velocity is in this direction, but this velocity has two rectangular components. Along the horizontal direction it has bx, and along the vertical direction it has by. So let's find the velocity at any instant of this projectile. So horizontal component of velocity is bx, that is u cos theta, and the vertical component of velocity is by. So using b equals to u plus at, by can be written as the initial velocity is u sine theta. We have seen that earlier. Here it is. The initial velocity was along the vertical component. It was u sine theta. And the acceleration is negative g because it is acting downwards. But the projectile is going upwards. So it is acting against the gravity. And time is as it is. So if we find the resultant velocity at point P, it is b equals to root under bx square plus by square. Now let's put the expression for bx and by. Bx is u cos theta and whole square plus by is u sin theta minus gt whole square. Now if we simplify this part, we will get u cos theta will be u square cos square theta, and this part is a minus b whole square, so it will be u square sine square theta plus g square t square minus 2u sine theta into gt. Now u square cos square theta and u square sine square theta is u square, because if we take common u square cos square theta plus sine square theta will give us 1, and then as it is, then it is u square plus g square t square and then minus 2u gt sine theta. So this is the resultant velocity. That means this is the velocity at any instant of the projectile. Now if the velocity b makes an angle beta with the vertical, then tan beta will be by bx, and by is u sin theta minus gt and bx is u cos theta. Now let's find the velocity of projectile at the end point. At the end of flight, the total time of flight is 2u sin theta by g. We have derived it earlier. So the resultant velocity will be b dash, and if we simply replace this value of t, this expression of t in the resultant velocity part, we will get u square plus g square, and then t square is 4, then t square is 2u sin theta by g whole square, that is 4u square sin square theta by g square, minus 2ug, and t is 2u sin theta by g into sin theta. Now here this term and this term are same, because here it is g square and g square gets cancelled, and here also g and g gets cancelled, and it is 4u square, and 2u into 2u is 4u square, and sin square theta, so sin square theta, so this whole term gets cancelled. So this is root under u square and it is u. So b dash is equals to u. That means at the end of the flight, the velocity b dash is equal to the velocity at the initial, that was u. So our v dash is equals to u. And if we find the tan beta, say it is u sin theta minus gt, and t is 2u sin theta by g, and here also g and g gets cancelled, and we are left with u sin theta minus 2u sin theta, that is minus u sin theta divided by u cos theta, and u gets cancelled, that is minus tan theta. So tan of minus theta, then beta is equals to minus theta. So the negative sign shows that the projectile is moving downwards. Thus in projectile motion, a body returns to the ground at the same angle and with the same speed at which it was projected. So that's it for today. We will meet in the next video. Thanks for watching.